Hi, this is Algebra 2, Lesson 26. We're going to talk about trinomial factors, trinomial factoring, and overlapping right triangles. We're starting on page 121. When we factor, we are dividing or undoing multiplication. When we multiply most binomials with one variable, we get trinomials. So here we have x plus 2 times x minus 1. If we multiply them together, we're going to get a trinomial. So let's try it. We've got negative 5 times 2 is negative 10. Negative 5 times x is negative 5x. X times positive 2 is positive 2x. And x times x is x squared. We add these together and we get negative 10 minus 3x and positive x squared. So we ended up with a trinomial. The factors of this trinomial are x plus 2 and x minus 5. Okay? Here we have two more binomials. We're going to factor it horizontally, and remember we can do that with the FOIL method. So the F stands for first. B times B is B squared. The O stands for outside, so B times negative 1 is negative 1B. And then the inside, I is for inside, so 4 times B. And then the L stands for last, so 4 times negative 1 is negative 4. And we put all this mess together and we get B squared plus 3B minus 4. So here is this trinomial, and its factors are b plus 4 and b minus 1. Okay? So, this is going from binomials to the trinomial. When we factor, we're going to go from the trinomial back to the binomials. What you need to notice here is that in both these cases, no matter which way we multiplied, our last term is the sum of the last terms in the binomial. 2 times negative 5 is negative 10. Right? Our middle term is the sum, well, the coefficient of the middle term is the sum of the last two terms in the binomial. Negative 5 plus 2 is negative 3. Okay? Over here, we had 4 and negative 4. Their product, 4 times negative 4 equals negative 4. Their sum, 4 minus 1, is the coefficient of b here, the middle term. So when we're factoring these, we need to look for factors of, first we need to put these in descending variable order. So we've got x squared minus 5x plus 6, and that will work much better. Now we need to look for factors of positive 6 that when added together are going to give us negative 5. Okay? So we can set up our parentheses for two binomials. X squared is just going to factor into x and x. This is positive 6, so our numbers are going to multiply to a positive 6, but they're going to add to a negative 5, which means that both of these are going to have a minus in here. Because two negatives multiply to a positive, but they add to a negative. Right? If it were one positive and one negative, then this would have to be a negative. Or if they were both positives, then this would have to be a positive. So since this term is positive and this term is negative, both of these terms have to be negative. Okay, so we need factors of positive 6 that add up to negative 5. The factors of 6 are 6 and 1. And in this case, we need two negatives. So we'll be negative 6 and negative 1, or negative 3 and negative 2. Negative 6 plus negative 1 equals negative 7. That's not helpful. But negative 3 plus negative 2 equals negative 5. So that's what we're going to use. Negative 3 and negative 2, and that will be the factors. Let's try another one. Here we have negative x squared plus 5x equals 14. Leaving this negative here out in front is going to make our life a little more complicated, so let's factor it out. We're going to pull this. This isn't an equation, it's just an expression. If it were an equation, we would just divide the whole thing by negative and throw it over on the other side so it'll be a negative 0. In this case, it's just an expression, so we can't do that. So we can't lose the negative. We're just going to pull it out in front. So we're going to divide all of the terms by negative 1, which makes this a positive x squared minus 5x minus 14. And that will be easier to work with. Okay. When you factor this, it's going to turn into two binomials. Do not lose the negative in front. We're just going to leave that there. And we have x squared, which is going to factor into x and x. This term is a negative, so that means one of these is going to be positive and one of them is going to be negative. It doesn't matter which way you write this. It doesn't matter if you do the x minus binomial first and the x plus binomial second, or if you do the plus first and the negative second. It doesn't matter. Okay? So now we need factors of negative 14 that add to negative 5. So the factors of negative 14 are going to be negative 1 and 14, or negative 14 and 1, negative 7 and 2, or negative 2 and 7. Okay, those are the factors of negative 14. 14 minus 1 is positive 13. Negative 14 plus 1 is negative 13. Negative 7 plus 2 is negative 5. And negative 2 plus 7 is positive 5. We need a negative 5, so we're going to use these terms. Okay, so then negative 7 and positive 2 goes here. That will be your answer, and you just leave the negative out in front. Just like that. You could multiply it in and come up with negative x minus 2 times x minus 7, or x plus 2 times negative x plus 7. Just leave it, or just leave it in front. It all works out the same. Okay? Just don't lose it. If you lose it, it's wrong. Okay, now we have factor 24 plus 6x minus 3x squared. Let's put it in variable order, descending by the powers. So we have 3x squared plus 6x, and it's actually negative 3x squared plus 6x plus 24. Okay, we would like to get rid of that coefficient because life is much easier without it. So we're going to divide everything, well, we're going to factor out a negative 3, which comes out to the same thing. We're dividing a negative 3 from all the terms. That leaves an x squared here. Negative 3, 6x divided by negative 3 is going to be negative 2x. 24 divided by negative 3 is a negative 8. Okay? We're going to once again leave the negative 3 in front of the binomials as we factor. So we'll have negative 3 and then two binomials. We have an x squared, so this will be x and x. We have a negative here, so one of these is going to be positive and one of them is going to be negative. And once again, it doesn't matter if you do negative and positive or positive and negative. It doesn't matter. Multiplication can go in either order. Okay, so now we need factors of negative 8 that add up to negative 2. The factors of negative 8 are negative 1 and 7, negative 7 and 1, negative 4 and 2, and negative 2 and 4. 7 minus 1 is 6. 1 minus 7 is negative 6. 2 minus 4 is negative 2, and 4 minus 2 is positive 2. So we need a negative 2, so we're going to use this pair. So we'll have a negative 4 and a positive 2. Okay? Let's try one more. We have 32x squared plus 12x cubed minus 2x to the 4th. So once again, we're going to start by putting these in variable order with descending exponents. So we'll have negative 2x to the 4th plus 12x cubed plus 32x squared. Okay, we need to get rid of the coefficient, and we can factor out some of the x's. The greatest common factor of these x's is the x squared. So let's pull out a negative 2 and an x squared. Oop, not that. So negative 2x to the 4th divided by negative 2x squared is just going to give us x squared. 12x cubed divided by negative 2x squared is going to be negative 6, and it leaves us with 1x. 32x squared divided by negative 2x squared is negative 16. Sorry about the squiggle in the middle. There we go. Okay. Now leaving the negative 2x squared in front, we're going to factor this into two binomials, the rest of it. So this is negative. So one of these is going to be positive and one of them is going to be negative. Here's an x squared, so these are both going to be x's. Now we need factors of negative 16 that add up to negative 6. So negative 16, our factors are negative 1 and 16, or negative 16 and 1. We have negative 8 and 2, or negative 2 and 8, or we have negative 4 and 4. 16 minus 1 is 15, 1 minus 16 is minus 15, 2 minus 8 is negative 6, 8 minus 2 is positive 6, 4 minus 4 is 0. So we're going to go with this one because it gave us a sum of negative 6. The 8 is going to go here and the 2 is going to go there. Okay? Now we're going to talk about overlapping right triangles. So here we have two overlapping angles. Once again, they're sharing A, and they both have a right triangle as their base. Because they're sharing A and both these right triangles equal 90, therefore these angles are also equal and they are similar triangles. By changing the lengths of the segments, we can create interesting puzzles to be solved with the properties of similar triangles and the Pythagorean Theorem. Woohoo! Alright, so here is an example. We're going to find A, B, and C. Here's A, here's B, here's C. They're both sharing this vertex. They both have right triangles there, which means that this angle and this angle have to be equal also, so they're similar. And we can set the sides proportionally. It might help once again to draw these angles separately. So we've got this guy, and then we have the big angle, which looks something like this. Okay? This side is A, this side is 6, and this side is 4. This side is this whole side. So this is A plus B, this is C, and this is this whole side. So this is 6 plus 4, which equals 10. Okay, now we can set up our proportions. We know that this is a right angle and this is a right angle. So these angles are corresponding. These two are the same vertex, so they equal each other. And that means that these two also equal, right? So we can find our corresponding angles, which are the ones that are opposite the corresponding sides, which are the ones that are opposite the corresponding angles. And we can set up some proportions. So let's use this one and this one because we have numbers for both of them. So we can say that 6 over 10 is proportional to A over A plus B. We're going from left to right this time. And 6 over 10 is also proportional to 4 over C. Okay? Now we can cross multiply and solve for these letters. So we have 10A is proportional to C times A plus B. This is not very helpful yet because there's really no way of getting rid of solving for either A or B. We can divide A from both sides, and we have 5/3 A equals A plus B. Really, that's not very helpful. Okay, let's go on this side. We have 4 times 10, and we have 6C. And they equal each other. So this is 40 equals 6C. Divide both sides by 6. And C equals 46, which equals 20/3. Okay? Alright, so we could solve for C. But we can't solve for A and B this way. It's just not being helpful. However, we can realize that A and A plus B are the sides that are opposite the right angle, which means they are the hypotenuse. Remember? And we can find the hypotenuse by saying 6 squared plus 4 squared equals A squared. Or, in this case, 10 squared plus C squared equals A plus B squared. Okay? So let's break that down. We have 6 squared plus 4 squared equals A squared. And over here we're going to have 10 squared plus, this is 20 over 3 squared equals A plus B squared. So this is 36 plus 16 equals A squared. 36 plus 16 is 52 equals A squared. So A squared equals the square root of 52, which when simplified equals 2 times the square root of 13. Alright, we can use the Pythagorean Theorem. It's going to come up with A plus B though. So instead of doing that twice, let's take this guy and mush him back into that. Okay? And that way we can solve for B. So we have 5/3 A, which is the square root of 52, equals the square root of 52 plus B, minus the square root of 52 minus the square root of 52, and this would be 3/3. So now we've got 2/3 times the square root of 52 equals B. And we can once again pull out the square root of 52 and do 2 times the square root of 13. So that is going to equal 2 times 2 times 2 times the square root of 13 all over 3, which equals 4 times the square root of 13 over 3. Not pretty. These are often going to come out not pretty. That's A, not A squared. Okay? It's okay if they're not pretty. Can you see that? My paper is sneaking down. Okay, so C equaled 20/3, A equals 2 times the square root of 13, and B equals 4 times the square root of 13 divided by 3. Okay, we could have found these with the scale factor, the sides. We could have found the sides using the scale factor instead of the proportion method. The book did it that way. So if you look at their example, they came out with the same answers. So you can do this the proportion way, or we could have found scale factors to find C. But either way, you're going to have to use the Pythagorean Theorem to solve for A, and then go back to either proportionals, the proportional way, or the scale factors to solve for B. Okay, they're messy. They're going to take lots of paper. Please show your work, and you can do this. Let me know if you have any questions. Thanks.